Today I'm going to talk about climate change and shrinking bison, an imminent nutritional cascade. When we think about climate change, we tend to think about how the world is becoming warmer. But knowing the consequences of a warming world is difficult to understand, especially for animals like North American bison. These grazers live in a complex ecosystem, and understanding the connections between the climate, the soils, plants, and ultimately the animals that eat the plants has not been well worked out. Generally, when we think about the effect of climate on the performance of grazers, such as bison, we tend to try and figure out what's going to happen to the quantity of food that's available to them, how much grass is going to be there. But there's another thing we have to think about, and that's the quality of the food that's available to the animals and how quality affects performance. Today I'm going to focus here on how climate change is going to affect the quality of food and how that ultimately cascades down or up to the performance of animals. As scientists, to use experiments to understand how climate change is going to affect grazers, well, experiments are of limited utility. When we think about how we typically run experiments for climate change, for something like warming, we would put heat lamps out and actually warm the soils and the plants that are there to stimulate a warming environment. But to get bison to stand under heat lamps or to have enough heat lamps to warm up an area large enough to incorporate them, well, that's relatively hard to do. So instead of using experiments, we tend to use cross-site comparisons. And what we do is we compare different places and then we say hotter places represent the future compared to the place that we're examining. So we can use a space for time substitution. In order to understand how bison might respond to a warming world, I took a look at continental patterns of bison weight. And for this, I took a look at 22 different herds of bison all across the US. And at each of these sites, bison were weighed in the fall. The database itself was over 250,000 weights, almost 300,000 weights of animals. And these are what some of the data look like. On the x-axis here, I've got the age of the animal. And this right here is for female bison. It goes from calves, which would be roughly 6 months by the time they're weighed in the fall, all the way over to over and above 10 years. On the y-axis, we have the mass of the animals, and this is in kilograms. And you can see, as we take a look at the weights of the animals in the cold, that those animals get bigger and then they more or less level off by the time they hit maturity. When we compare the weights of the animals in a cold place to, say, a hot place, you can see that the animals in the hotter place gain weight at a slower rate and ultimately are smaller animals. This difference right here is on the order of 100 kilograms, so over 200 pounds, 250 pounds. The consequences of a warming world, if we use our space for time substitution, essentially say that as we go from cold to hot, those animals are going to get smaller, they're going to gain less weight. These were the female bison, and when we take a look at the data for the male bison, we really see the same pattern. Here the x-axis again is age, y-axis here is mass in kilograms. This is a smaller age interval because most places don't keep their male animals beyond 7 years. But here's the pattern for cold. You can see a linear increase almost all the way up to 6-7 years, with on average for this cold site, which was the South Dakota site, being roughly 900 kilograms. When we switch to the hot site and take a look at the rate at which bison gain weight, you can see that at the hot site, bison were smaller. So right now we're comparing, this was Oklahoma, this was South Dakota, and you can see that for the males, that difference is over 250 kilos. So we're talking 500 pounds difference in a 7-year-old male at a cold site versus a hot site. So what we take away from this is that warming shrinks bison. As we go into grasslands that are warmer and warmer, bison get smaller and smaller. We can actually quantify this relationship, and I can show it to you on one graph. On the x-axis here is mean annual temperature in degrees C, and this ranges from 4 degrees all the way in the northern part of the Great Plains to 15 degrees in the southern part of the Great Plains. And these are the data for males and females. On the y-axis I have mass. If we take a look at what happens for the weight of the males once we standardize for age, for example, is that as we go from cold to hot, the animals get smaller. And it's the same thing for the females. As we go from cold to hot, the animals get smaller. So what this shows is that as grasslands warm, we can expect the weight of the bison to decrease. Those bison are going to shrink. So what's the mechanism? How does this happen? Well, to start to understand that, I'll show another data set where we took a look at continental scale patterns of nutritional quality of the grass that grazers eat. And when we talk about quality, what it is about grass that determines how much weight animals gain, we're essentially talking protein. It's the protein concentrations and not really the energy concentrations that are most limiting to bison. So when we take a look at a bison and we watch it eat, it's relatively difficult to understand what species they're eating and what quality of plants that they're consuming just by watching them. An easier way to do that is to take a look at their diet after they're done eating it. And we essentially go out and we take fecal samples at different times of year. And from these fecal samples, we can determine the quality of the grass, essentially the protein concentrations of the grass and other plants that those animals were eating. This is done with near-infrared spectroscopy. And what I'm going to show here is the near-infrared spectroscopy data for cattle all across the U.S. And we're going to use cattle here because we have a much better data set for cattle as opposed to bison. For these data, I worked with Texas A&M, the Grazing Animal Nutrition Lab. And the Grazing Animal Nutrition Lab, what they do is they receive samples from all over the U.S. These are typically ranchers who have cattle that are out in pastures or free rangelands. And at each one of these points is a place where somebody had taken a fecal sample at a particular time of year, sent it down to Texas, and had the quality of their diet analyzed. And what we can do for each one of these regions, like this region here, which is the Sandhills, up here, the Northern Great Plains, we can take a look at the patterns of nutritional quality over the year and then compare them along, for example, a north-south gradient, which is cold to hot. This is just one of the patterns that we get. This is the northern shortgrass prairies, so thinking Montana and the parts of the Dakotas. On the x-axis, we have day of year, 365 days in the year. This is January 1st, December 31st. And this is the crude protein concentrations of the plants that they were eating. Low quality diet down here, high quality diet up here. Here's the pattern that we see, that the quality of the diet is relatively low. It increases in the spring into the midsummer and then gradually declines until it levels off in the fall and the winter. What we can do with each of these curves is quantify essentially what the maximum crude protein concentrations are at a place and use that as a point of comparison. In addition, we can take a look at what the minimum crude protein concentrations are and compare that across sites. And that'll let us know as we get to hotter sites, for example, does peak crude protein concentrations decline? And that would tell us that the quality of the diet might be behind having bison get smaller as we go from cold to hot sites. Well, here's the data. Each one of these points represents a different ecoregion within the U.S. On the x-axis, we have mean annual temperature. On the y-axis, we have the crude protein concentrations of what those cattle were eating. And you can see that as we go from cold to hot, those protein concentrations decline. The solid circles up here are the maximum crude protein concentrations, and these right here are the minimum crude protein concentrations throughout the year. So if you're in a hotter site, you're going to experience lower maximum crude protein concentrations, and you're going to experience lower minimum crude protein concentrations. There's much greater nutritional stress for cattle in a hotter grassland than in a cooler grassland. Here's a map of protein concentrations for North America, and this is from the cattle, the same data that we just were looking at. When we get to cooler sites, for example, colors are red, and that means higher protein concentrations. And by the time we work our way down the Great Plains into a hotter and hotter region, we're into lower and lower protein concentrations. So essentially, hotter places, less protein. So why is that? Well, essentially, and I won't get into too many details here, but as soils warm, they get run down. The amount of nitrogen that they're able to produce decreases, and that means that there's going to be less protein in the grass for grazers to eat. Less protein in the grasses has a consequence too, and that's going to be for smaller animals. So as we look into the future, we're going to ask, what does the future hold for bison in North America? Well, essentially, we're facing a warmer world. That part is clear. In a warmer world, if we trust our patterns across the Great Plains, across North America, we're going to see less protein in the grass, and that's going to mean smaller bison. Now, I haven't talked much about this too, but as a finishing point, I'll also state that what holds for bison is going to hold for cattle. As those temperatures warm, the 100 million cattle that we have in the US are also going to experience greater nutritional stress. They should gain weight at a lower rate and be smaller. When we take a look at what the economic impacts just on cattle would be, for every degree Celsius increase in temperature, we're expecting somewhere on the order of $1 billion in decline in the production of meat coming off of grasslands. So to finish up and think again about bison and how they're going to respond to a warmer world, there's a whole set of complicated factors that are in play in determining the performance of these animals. How much weight they gain, how many calves they are produced in a given year, for example. None of these are necessarily isolated, but if we think about what the consequences of a warmer world is, we're thinking we're going to have warmer temperatures in the atmosphere. That's going to lead to warmer temperatures in the soil. That's going to change the way the soils work. They'll produce less nitrogen for plants, which is going to mean less protein in the forage that they eat. And animals that get less protein are going to end up smaller. So in the future, having animals that are large males that are on the order of 2,000 pounds, 900 kilos, it's going to become a lot rarer. Now, the health of the animal isn't necessarily going to change, but we do expect bison in the future to be smaller than they are today and they were in the past.